Hello students, welcome to Anne's classes. Let's do Exponents, Chapter 2, Test Yourself. Test Yourself, page 39. And the first question is the multiple choice type. Choose the correct answer from the options given below. Question 1. The multiplicative inverse of this statement is which of these answers? So this is what we're going to work out. So let's write down that question. So that is 8 raised to the power of 0 plus 5 raised to the power of 0 into 8 raised to the power of 0 minus 5 raised to the power of 0. So we need to work this out. Now we know that any number raised to the power of 0 is 1. So this will be 1 plus 1 into, here it will be 1 minus 1. So 1 plus 1 is 2 into 1 minus 1 is 0. 2 into 0 is 0. Now this number 0 does not have a multiplicative inverse. So it cannot be 0, it cannot be 49, it cannot be 1. It is undefined. So 0 does not have a multiplicative inverse, so it is undefined. Question 2. So here we have an operation within brackets and then we have division and this. So we have to work this out first. So let's work out what's within brackets. Now 1 by 4 raised to the power of minus 2. We can change the power to a positive power if we write the reciprocal. So 1 by 2 will now become 1 by 4 will now become 4 by 1 raised to the power of 2. So let's write that here. So that becomes 4 raised to the power of 2. So the power is now positive. Similarly, on the other side, 1 by 3 is raised to a negative power. Let's write the reciprocal. So 1 by 3 becomes 3 by 1 or simply 3 raised to the power of 2. And this whole thing is now divided by 1 by 5 which is raised to the power of minus 2. Again, write the reciprocal and change the power to a positive power. So now this becomes 4 raised to the power of 2. 4 4s are 16 plus 3 raised to the power of 2. 3 3s are 9. 16 plus 9 divided by 5 5s are 25. 16 plus 9 is 25. 25 divided by 25. So we know that 25 when you divide it by 25, both can be divided by 25 itself. So 25 ones are 25, ones are 25. Our answer is 1. Now which option is that here? So look at the options here. The option B has the answer 1. So our answer here is option B. Question 3. If 3 raised to the power of 4 into 9 raised to the power of 3 is equal to 9 raised to the power of n, then we have to find the value of this n. So now to find the value of n, let's write down the question. 3 raised to the power of 4 into 9 raised to the power of 3 is equal to 9 raised to the power of n. Now we have learned in the laws of exponents that when the base is the same, we can add up the powers, isn't it? Here the base is not the same. So let's make the base the same here on the left hand side. So now this will be 3 raised to the power of 4 as it is. Now we can write 9 as 3 square, isn't it? That is 3 into 3 is 9. So instead of writing 9, we can write 3 square and this whole thing is raised to the power of 3. So that is 9 raised to the power of 3. Similarly here also, instead of 9, we can say 3 raised to the power of 2. 3 3s are 9 and that is raised to the power of n. So this is equal to 3 raised to the power of 4 into, now when a power is raised to another power, you can multiply the powers. So 2 3s are 6. So this will be 3 raised to the power of 6. Similarly here, 3 raised to the power of 2 into n is 2n. So this is 2n. So now we also know that when the bases are equal, the powers also are equal. First, let's do this part. When the base is the same and its multiplication, we can add up the powers. So this will be 3 to the power of 4 plus 6 is equal to 3 to the power of 2n, or 3 to the power of 10 is equal to 3 to the power of 2n. Now the base is the same. That means the powers are equal to each other. 10 is equal to 2n. 10 is equal to 2n, or we can put 2n this side and say 2n is equal to 10 without changing anything, only the sides. Now let's find the value of n. N will be equal to 10 divided by 2. Why divided? Because this is multiplication. When we take it to the other side, it becomes division. Now here we can cancel. 2 5s are 10. So now we have got the value of n. N is equal to 5. So this is our answer. Now let's look at the options here. Option A is 5. So let's tick option A. Question 4. If 5 by 6 raised to the power of 5 into 6 by 5 raised to the power of minus 4 is equal to 5 by 6 raised to the power of 3x, we have to find the value of x. So this one will remain as 5 by 6 raised to the power of 5. Here the power is negative, so we can change the power to positive by writing the reciprocal of this. So let's do that first. So it will be 5 by 6, the first rational number remains the same, 5 by 6 raised to the power of 5 into, now here instead of 6 by 5, we can write 5 by 6 so that the power now becomes positive. So now the power is 4 and not minus 4. And this is equal to 5 by 6 raised to the power of 3x. Now here we know when the base is the same, we can add up the powers, isn't it? So 5 by 6 raised to the power of 5 plus 4, adding up the powers. 5 plus 4, and this is equal to 5 by 6 raised to the power of 3x. So this is equal to 5 by 6 raised to the power of 9, which is equal to 5 by 6 raised to the power of 3x. So now can you see that the base is equal? So the base is 5 by 6 here and 5 by 6 here. So when the bases are equal, the powers are also equal. So this will be 9 is equal to 3x or 3x is equal to 9. Now we can find the value of x. X is equal to 9 divided by 3. Why division? Because here it is multiplication. So here 3 3's are 9. That means we have found the value of x. X is equal to 3. Now let's look at our options here. And the option D is 3, and that is our answer. Question 5. 2 by 5 raised to the power of minus 8 divided by 2 by 5 raised to the power of 5 is equal to what? Here the base is the same and it's division. That means you can subtract the powers. So here I can write this as 2 by 5 raised to the power of, now we have minus 8 minus 5. We can subtract the powers. So this becomes 2 by 5. Now this is raised to the power of minus 8 minus 5. Signs are the same. Put the same sign and add 8 plus 5 is 13. So it's raised to the power of minus 13. So look carefully. So here also we have minus 13. Here also we have minus 13. But the base is 2 by 5. So look for it carefully. So this is our answer. 2 by 5 raised to the power of minus 13. Question 6, statement 1. X to the power of 0 plus y to the power of 0 in brackets into x plus y raised to the power 0 is equal to 1, and x and y are both not equal to 0. Now let's consider this. This is raised to the power of 0. Y is also raised to the power of 0. X and y, when you sum it up, and that's added raised to the power of 0. Now this is very important. Any non-zero number raised to the power 0 is always equal to 1. Now this is something we know. You take any non-zero number, and if it is raised to the power of 0, it's always equal to 1. If I take 3 raised to the power of 0, this is equal to 1. If I take 19 raised to the power of 0, this is equal to 1. So any non-zero number that is raised to the power of 0 is equal to 1. So now let's consider the question that's given to us, that is this equation. So x to the power of 0 plus y to the power of 0 into x plus y, the whole raised to the power of 0 is equal to 1. This is what it says. Now let's take x to be 1 and y to be 2. Let's see whether it happens here. So 1 raised to the power of 0 plus 2 raised to the power of 0. So x is 1 and y is 2. And here within brackets again, x is 1, y is 2, the whole thing raised to the power of 0. Let's see what it is equal to. So here 1 raised to the power of 0 will be 1, because any non-zero number raised to the power of 0 is always equal to 1. So this is 1 plus 2 raised to the power of 0 is also 1. And here 1 plus 2 is 3 and 3 is raised to the power of 0. Let's simplify this. Now 1 plus 1 is 2. 2 into 3 raised to the power of 0 is 1. 2 ones are 2. But here what does it say? It says statement 1 says it is equal to 1. Here it says it's equal to 1. And we know 2 is not equal to 1. That means the first statement is false. Statement 1 is false. Now let's look at statement 2. It says 1 plus 1 into 1 minus 1 is equal to 2 into 0 is equal to 0. Let's work it out and see whether that is true. 1 plus 1 into 1 minus 1. Let's work this out. 1 plus 1 is 2. 2 into 1 minus 1 is 0. So 2 into 0, correct. We've got here 2 into 0. And how much is 2 into 0? This is equal to 0. That means statement 2 is true. Statement 1 is false. So now, which is our correct option? Statement 1 is false and statement 2 is true. So option D is our correct answer. Question 7, we have an assertion reason question. Let's analyze both assertion and reason. So negative 100 raised to the power of 3 is negative 10 lakh. So let's write that down. Negative 100 raised to the power of 3 according to the assertion is negative 10 lakh. Let's calculate this. So this means negative 100 multiplied 3 times into negative 100 into negative 100. So let's do this multiplication. Let's multiply these two first. Negative 100 into negative 100. Minus into minus is plus. 100 into 100 is 1 followed by 4 zeros, that is 10,000. Now let's multiply that with negative 100. Now the signs are different. So plus into minus is minus. 10,000 into 100 is 1 followed by 6 zeros. 1, 2, 3, 4 here and 2 more zeros. And when you place your commas, you know this is now negative 10 lakh. So assertion, when we analyzed, we found it to be true because according to that, negative 100 raised to the power of 3 is negative 10 lakh. So assertion A is true. So assertion is true. Now let's analyze the reason. Now the reason, negative p raised to the power of q is p raised to the power of q. That is if q is even. So the negative integer now becomes positive only if this power is even. So when a negative integer is raised to a power that is even, the answer is positive. And we've learned that. If n is even, negative 2 raised to the power of n is positive. So any number, negative number, if it is raised to a power that is even, the negative number becomes positive. As we can see here, let's try an example. Now suppose we take negative 3 and raise it to a power that is even. So let's raise it to 2. Now let's multiply this and see negative 3 into negative 3. Minus into minus is plus. 3 3s are 9. So as you can see, the negative number that was raised to a power that was even, because the power is even, the answer is positive. If the power is odd, if it's an odd number, the answer will be negative. That means both the statements are true. The reason R is also true. So both the statements are true, but reason R is not the correct explanation for A. Reason R is true, but the explanation does not go along with A. So here, which one is our correct answer? Option B, which says both A and R are correct, but R is not the correct explanation for A. So this is our final answer here. Question 8, another assertion reason question. Let's analyze assertion A. So here it is 7 raised to the power of 0 plus 2 raised to the power of 0 into 7 raised to the power of 0 minus 2 raised to the power of 0 is equal to 0. Let's calculate that and see. So 7 to the power of 0 plus 2 to the power of 0 multiplied by 7 to the power of 0 minus 2 to the power of 0. Let's work this out and see. So we know that any number raised to the power of 0 is equal to 1. So this is 1 plus 1. And here it is 7 raised to the power of 0 is 1 minus 2 to the power of 0 is 1. So here what do we have? 1 plus 1 is 2 into 1 minus 1 is 0. 2 zeros are 0. So that means the final answer here is 0 and the assertion also is 0. That means this statement is true. Assertion is true. Now let's analyze the reason. Any number raised to the power 0 is always equal to 1. Now this reason is also true, and this is the correct explanation for assertion A. So which is our final answer? Option 1. Both A and R are correct, and R is the correct explanation for A. So this is our final answer. Question 9, let's analyze the assertion. What does it say? 1 by 5 the whole raised to negative 5 into 1 by 2 the whole raised to negative 5. So when the power is negative, to make it positive, we can write the reciprocal. So what we're going to do is we're going to work out the left hand side of this equation to see whether we get the same as the right hand side. So let's take down the left hand side of the equation, that is 1 by 5, the whole thing raised to negative 5 into 1 by 2. So that is 1 by 2, again here also the whole raised to negative 5. We've taken only the left hand side of this equation. We're going to see whether we get the same as the right hand side. So we're working that out. So when the power is negative, to make it positive, we write the reciprocal. So 1 by 5, reciprocal is 5 by 1 or simply 5. So this makes it 5 to the power of, now the power is positive, into, similarly here also 1 by 2, it is raised to a negative power. So for the power to become positive, we write the reciprocal of 1 by 2, which is 2 by 1 or just 2 to the power of 5. Now here this is 5 to the power of 5 into 2 to the power of 5. Now we have another property where we have a to the power of m into b to the power of n. M can be written as a into b, the whole thing raised to the power of m. Since the power is the same, we can say a into b, the whole thing raised to the power of m. We can do the same thing here. So here we can say 5 into 2 and the whole thing raised to the power of 5 because the power is the same. 5 2s are 10, 10 to the power of 5. So left hand side is 10 to the power of 5 and the right hand side, let's see what the right hand side is. Let's go back to the question. The right hand side is 10 to the power of negative 5. 10 to the power of negative 5. So as you can see, 10 to the power of 5 will not be equal to 10 to the power of negative 5. 10 to the power of 5 will not be equal to 10 to the power of negative 5. That means the assertion is false. So we have just found that out. Assertion is not true. It is false. So now let's analyze the reason. Now the first part of the reason says p raised to a negative power will be equal to the reciprocal 1 by p raised to the positive power. So this is a property of exponents that if a base is raised to a negative power, it is equal to the reciprocal of that base raised to a positive power, positive exponent here. So this part is correct. Now let's look at the second part. So the second part is 1 by p raised to the power of negative q, and it says p is equal to, this is equal to p raised to the power of q. So when this is negative, to make it a positive power, we write the reciprocal. So 1 by p, the reciprocal is p and the power is q. Left hand side is p raised to the power of q. The right hand side is also p raised to the power of q. So what do we understand? Reason, both the parts of the reason, when we analyze, it's true. So we can write this as true. So assertion is false, reason is true. That means our answer is option D. Assertion is false, but reason is true. This is our answer. Question 10, let's analyze assertion. So let's write this down and see what we're given. We're given P minus Q raised to the power of negative 1 into p raised to the power of negative 1 minus q raised to the power of negative 1, and this is equal to negative pq raised to the power of negative 1. So first let's analyze the left hand side. Let's simplify this and see whether we get the same thing as the right hand side. So let's work on this. Now we know that when any integer is raised to a negative power, to make that positive power, you write the reciprocal of this. That is, here in this case, negative p by q. Now p minus q raised to the power of minus 1. Now when I write this as the reciprocal, the power -1 becomes positive. So now it is raised to the power of 1. Because it's raised to the power of only 1, I can leave out that 1 and write it as it is. So this one, p minus q raised to a -1, can be written this way. So this is how we have written this way. Now let's do the same thing with the other part. So this remains here. Now let's look at this. So here also p is raised to a negative part, -1. That means I can write the reciprocal 1 by p to the power of 1, which is p, minus 1 by q to the power of 1, which is q. So now what have I done? I have just changed the powers to positive by writing the reciprocal of what is given to us in the question. Now we have to multiply, because here this means this one into this, isn't it? So 1 into the numerators that we need to work out. Now this is fraction subtraction, so we have to first simplify this and then do the multiplication. So here 1 by p minus q remains the same. There's nothing more to simplify here, whereas in the other part we have to simplify. Now here 1 by p minus 1 by q fractions, so we have to find the LCM of the denominators by multiplying p and q. P into q is pq. So the denominator is pq. Now we have to get the new numerators. Now here it is, you already have a p, we have to multiply by q. So multiply 1 also by q. So 1 into q is q minus, on the other side, q is already there, so we need to multiply with p. So 1 into the letter p. So here what do we have? Q minus p. Now we can multiply 1 into the numerator here. So 1 into the numerator, q minus p, will give us back q minus p itself. Now in the denominator, we have p minus q into pq. P minus q into pq. Now we can cancel these two if we have it in the same form. Here we have q minus p, whereas here we have p minus q. Now how can we get this into the same form? So I'm going to try and make this p minus q. So for that, what we do is we put a minus sign outside and write this as p minus q. Remember, if you do this, you should get the same answer when you multiply. So let's multiply and see. Minus into p is minus p, we have minus p there. Minus into minus q is plus q, we have plus q there. So whenever you have to change the order, all you have to do is put the negative sign outside and write p minus q inside. Now in the denominator, we have p minus q into pq. Now why did we make this change here? We made this change here so that we can cancel with the denominator. Can you see? Denominator is in this form. So q minus p also we brought it into that form. Now we can cancel. So this is cancelled and this is cancelled. So in the numerator we just have -1. So this is minus 1. In the denominator we have pq. Now what we have done is the left hand side. This is the left hand side. LHS. Now let's see whether this is equal to the right hand side. So right hand side is negative PQ minus 1. That's what it says, it's equal to that, isn't it? So equal to negative of PQ raised to the power of minus 1. So negative PQ, the whole thing raised to the power of minus 1. Now here also I'm going to change my power to positive. That means I need to write the reciprocal of PQ. So the negative sign remains and the reciprocal of PQ is 1 by PQ. So now what do I have on my right hand side? I have negative 1 by PQ, which is the RHS. Now can you see RHS and LHS? They are the same. So LHS is equal to RHS. We can write here. So the left hand side, so LHS is equal to RHS. That means assertion A is true. Now let's look at the reason. A to the power of minus 1 and A to the power of 1 are multiplication reciprocal to each other, which is true, which we just saw here, isn't it? Now, the option that we're going to choose is the first one. Both A and R are correct, and R is the correct explanation for A, as we just saw in this. So what is our answer here? Both A and R are correct, and it's a correct explanation for A. That's all for now. See you in the next video.